Okay, great. Then let's continue. I will show you now another way to run your jobs using scripts. Um, I pasted a link into chat where you can find an example of a job script so that we don't need to type everything. So open that link, go here to this chapter, command S batch, and here you will find this file, job.sh. Press copy link address to copy the link to it, and then we can go to our command line and use the tool wget to download the file. Just press, just right click and it will paste the link to the file. And it will download it. And if I type ls to display the contents of my home folder, you can see that there is this new file, job.sh, inside. Did you manage to do that? Hands up. Great, great, great. Okay, now let's look what's in this file. I will just use the built-in command line text editor Nano in order to edit and display the contents of this file. Of course, for serious work, I don't recommend using Nano. I recommend using Visual Studio Code. There is even a guide on our page. Let me find it. So here we have instruction, VS Code and SSH. Is it in English? Unfortunately, it's not yet translated. So too bad for those who don't know English, but you can always use ChatGPT to translate it. So I will just paste the links. Here is a guide on how to set up your VS Code in order to connect to the cluster, and you can edit files and download and upload data directly from VS Code for ones who are using it. It's quite convenient, and I recommend this of connecting to the cluster this way. Otherwise, we will be just during this workshop, we'll be just using Nano in order to edit files. So let's open Nano, and we get this script inside. This is a bash script, Linux bash script. Basically, are just commands that are written in a text file that are executed by the terminal. And using this header, so as batch and then some switches, we can define our Slurm job inside this kind of script. And there are some switches which I already showed, for example, end tasks, nodes, and there are some that I haven't yet shown. And we could use all of these switches here also when using srun to run our jobs, but this is just another way to execute jobs. So we put in front as batch and then state the settings or the configuration of our job. So here with the switch partition, we tell it to execute on the partition all. Here with the switch job name, we set up the name of the job. This is what is displayed when you type in SQ. It will display this string here. Let's change it So let's type my first job. Let's leave end tasks to 4. Let's leave nodes to 1. And then we can change the memory per CPU settings with this switch. So the default setting is 2 gigabytes per CPU. I change it here to 100 megabytes because I'm executing host name. This is a very simple application and it doesn't need a lot of memory, so why waste it? And I set that to set the setting to 100 megabytes. Then I have this output, and here I tell Slurm into what text file to store the printout which my application makes. So what will be printed out by hostname will be stored in a text file with this name here. So I can change this to whatever, but let's leave it to myjob.out. And then I can change also the time limit for my job. As I said before, the default time limit is 30 minutes. You can extend it on the partition all to 2 days. Here I shorten it to 1 minute because I know that my job won't execute that long. It just prints out the node name. So I reduce the execution time to 1 minute. Why waste? Why there is no need to confuse Slurm that my job will take 30 minutes if I know that it won't. And then after these parameters, we take the tasks which should be executed in my job. And we have to put srun in front and then the name of our application, script, whatever. We need to put this srun in front in order to tell Slurm to use all these resources stated here and settings in order to execute my application. Okay. Now I save this file because I changed it a little. Maybe I can change it a little bit more. Yeah, one thing is missing. I'm not using a reservation here. Where's my... Okay, I will add another line and I will tell it to use the reservation. In order to not to wait in the main queue. Now let's save the file. Just press Ctrl O and enter, and then Ctrl X to exit Nano. And then let's try to run this job. So we type in a new command that is called sbatch and the name of the script which defines our job. Okay, sbatch job sh. Oh, yeah, I forgot to mention. Now it should the execution of jobs should work on your accounts. Please try it if you haven't, but now it should work. And I got, when I pressed enter, I got a note submitted bad job with this job ID. And now my job is running in the background and I can check if it's finished, sq-me. And I see that the list of jobs is empty. So that means that my job finished. And when my job finished, it produced this file, myjob.out, and here are the contents. Inside, I will find the contents produced by my job. So I can display them using cat, and the name of the file, .out. Okay, and yeah, I can see I run 4 instances of host name, and in the file I can find four lines. Let's open again our job using Nano, so nano job.sh. And let's change it a bit. So instead of running postname, I will run another system program called sleep. Now what sleep does is just sends the process to sleep. It basically does nothing. And we can tell it for how long it should be doing nothing. Let's say that we set the time in seconds to 30 seconds. So for 30 seconds, this application will be doing nothing. It will just waiting to finish. Let's save the file, Control O, Enter, Control X, and let's try to run it. So as batch and job.sh. Okay, now it's running in the background on some compute node, and I can check what is happening using SQ. And I can see now that my job is running. Here I can see the time. If I run SQ again, it's now running for 15 seconds. This is the ID. It's running on partition all. This is the name. This is the user from which I'm executing my job, and it's in state running on WN140. And now it's okay, 33, and now it's finished. The time here does not refresh so fast, so it could miss for a few seconds up. So that's nothing to be worried about. It slipped for 30 seconds, and now it's finished. Of course, it didn't produce anything in the myjob.out because it just slips. Let me run this job again so I can show you how to cancel this type of job. So Control C in this case won't work because the job is running in the background. So I run it again. And now I can cancel it using scancel and typing the job ID. And if I go sq-me, there are no more jobs running because I canceled that specific job. If you have only one job running and you don't want to fiddle with the job ID, you can just type scancel -me and it will automatically cancel all your jobs. That's a little bit dangerous, of course, if you are running multiple jobs and there is something important running for a long time and then you type in scancel -me, everything will get terminated. So be careful about using that one. It's better to specify exactly which job you want to cancel. So this is another way, or I will guess the usual way with which users are creating and running jobs, so that you create a file in which you specify all the settings for your job. You specify the task which should be executed inside job, and then you run it using sbatch. Srun is more like if you're testing something and running things interactively, then you use srun. But when you want to run something for a long time in the background, you just use sbatch. Even if you log out from the cluster, the job will be still running in the background and waiting for you till you log back to the cluster and check if it's already finished and if the results are there. Did you manage to run your as bad job? Hmm. Okay, great. Now let's talk a little bit about user software before I hand in the workshop back to Radko. So for now, all we have been doing, we were executing some system programs which are present on every Linux machine. So not very interesting. Usually you want to run some, let's say, I don't know, Python code, some physical application or whatever. So you have some user program which you want to run on the cluster. And a lot of times this software is not installed. Now, how is this managed? How is user software managed on a cluster? There are different ways. The simplest way is using modules. So the cluster already has a lot of applications and libraries and programming languages installed, but they are not available immediately from the command line. Now, and it's using modules, as they are called, to manage what the user sees and what it doesn't see. And we can check what is already present on the cluster by using the command module spider. And this will print out all the different kinds of libraries and applications installed on the cluster. For example, I don't know what you are familiar with. Here is Anaconda for those using Python. I know Blender, if you know that one. CMake, CUDA for GPUs. Some chemical software for chemistry, different compilers, different versions of different software, different versions of Python, and so on and so on. A lot of stuff is already installed. Of course, there is always the option that you won't find something you need installed. But let's say, and Radko will show you how to deal with that. But let's say we have a module which we have the software we need inside the module. What do we do? So in the next part of the workshop, we'll be processing video. And in order to process video, we'll be using a command line application called ffmpeg. And of course, to execute it, the program is called ffmpeg. And if I type this command in the command line, I get ffmpeg command not found. So this application is not available for me right now. Now I can check if there exists a module which contains this application. So I go module, spider, ffmpeg. Okay. And I can see, yes, there is a module called ffmpeg which contains the application I need, and also different versions of this application. And now I want to use it. So what do? I say module, spider, no, not spider, but module load, ffmpeg. I do that. And now this module or this application is visible to me. And if I type now ffmpeg in the command line, I get some output, and it prints out the current version installed, and so on and so on. So now this application is available for usage on the cluster and on the compute nodes. For example, I know probably a lot of you are using Python, and if I write Python in the command line, again, I get command not found. But if I go module spider Python, and let's check if there exists, there is a lot of, okay, yeah, there are a lot of packages modules which use Python, so all are displayed, but I should find the only Python, for example. Where is it? It's under P, I guess. Okay, here it is. So we have Python, we have different versions of Python. The last one is 3.12. Okay, let's try to load it. I go module, load Python, and let's run this. And okay, it loaded Python, changed some libraries accordingly. And if I now run Python in the command line, I get the Python interpreter online. So this is one way of using user software. Now another way, if the user software is it is possible, if it is possible to install user software in your home directory and it works that way, then you can, of course, install it by yourself. It just doesn't allow you, of course, to install some software system-wide or cluster-wide because that is only possible for administrators of the cluster. You can only install your software in your home folder if it allows you to do that. The third option is, of course, to use containers, and Radko will later show you quickly how it can be done using containers. Any questions? Not for now. So next thing will be as a proof of concept application on how, let's say, work can be speed up on the cluster. We will be doing, as I mentioned, some video processing. And we'll be using FFmpeg for that. Let's just try a simple example on how this can be done on one compute node. So first things first, we need to load FFmpeg module if you haven't yet. I have. So if I type FFmpeg one more time, I can see that FFmpeg is working. And now we need a video so that we can process it. And if you go here, let me paste the link. You will here find this link to a short video. You can also open it and see what it is. It's a cartoon made with Blender on some llama trying to cross the street or highway. Okay, someone is stuck. Control D, you have to press Control D or type exit with brackets. Control D is to exit Python. Okay, so copy link to this video and type wget in order to download it to the cluster, and wget and link to the video. Okay, I have it here, and now we can do some stuff with it. So don't be worried about using about all the switches connected with FFmpeg. The point of this workshop is not to teach you how to use FFmpeg. It's quite complicated software to use. These are just examples, and you should take them as granted. So I will explain shortly what a certain command does, but don't worry about switches. You probably are not doing video editing on your own. If you're doing it, then you probably know how to use FFmpeg. If you're not, then it doesn't matter. So let's, for example, try to lower the resolution of our video. If I type ffprobe and the name of my video, that is ll.mp4. This ffprobe is also part of ffmpeg module, and it displays the information about a video. And somewhere in this printout, you are able to see the resolution of the video. So this is the resolution. So it's 960 by 540. And we will try to lower it using FFmpeg. Just copy this command here. So in the chapter lowering resolution, and paste it, right click into the command line. And now what this do? I messed up. Here. Copy, paste. Okay, and now what this does is it runs one task on a certain compute node, and it executes FFmpeg. It tells here I state what is the input file, so it's my video, and then it states that the audio part of the video should be just copied. This is this dash codec A copy. This means that the audio should be just copied, and video should be filtered with the scaling filter, and the new resolution should be 640 by 360, and the output video should be stored in this llama small.mp4. And if I run this, the FFmpeg starts executing, and it tells you what's the speed with which is processing the file, and now it finished. And if I type ls to print out the contents of my home folder, I can see now that I have a new video in my folder. And let's check if the resolution is correct. ffprobe. And let's find where is the resolution. Here. It's now 640 by 360. So I effectively lowered the resolution. If you have connected using CyberDuck, you can now download this video to yourself. Where is my CyberDuck? In just a moment, let's try this. So let's open connection to the cluster. We need to select SFHTTP, and we go HPC, login. And username is link045, and password is okay. Let's connect. Okay, now I can see my video here, and I can download it to my computer, and then to see what was the result of this video processing. Uh, okay, that is all from my side, and now I leave it to Radko to show you how to speed up this process of processing video using multiple CPU cores and possibly even multiple nodes um, on this harness cluster. So I hand it to you, Radko.
Thank you, Dower. Can we hear each other? See each other? Okay, great. So thanks, Dower. Thanks for this for detailed explanation of how to use srun and similar commands and a great introduction for this final part of the workshop. So here we will try to parallelize to optimize the computing using FFmpeg. Now, in the previous case, Dover only used one processing core to execute this command. However, we have a lot of a lot of cores, even GPUs, available to process this video. So we will go through here. We will go through we will know a couple of different strategies that can be useful, that can be abstracted and useful for your work. So let's first share screen. Okay, share. Okay, can you see my screen? Okay, great. Now, first of all, I already logged in to Arnes HPC. Once again, if I do host name, I get this text, which is good. I am on the Arnes cluster. Then I have prepared three folders with already prepared video. So if you don't have video, please download it now. Okay, first strategy will task one. Okay, here in the first folder we have only the input video, and in the first video we will tackle the problem how to download video. Okay, how to download video. Okay, once again, I will so here, okay, let me this is link to the page. Then what I do here is go to the, let's say, go to this link llama.mp.stri. Then I copy the connection, okay, and then I use wget command. So wget and this thing, and it automatically downloads the video to my folder. Okay, I'm pasting this in the chat, this command. Okay. Muniva, did you download the video now? Oh, great. Okay. So so in the first part, we will show the naive approach of how to process video sequences in parallel. Let's say, okay, let's say the processing of video sequences is part of the so-called embarrassingly parallel problems, where we can divide the original sequence, original data into chunks of it, and Okay, I can paste in the Windows command prompt. Okay, Pedro, try to reconnect or right click, then paste. Okay. Now, okay. Okay. Now it worked. Okay, great. Pedro, okay. Okay, now let's go to the now let's so concerning the let's say this embarrassing parallel problems, the approach is that we divide the data into the chunks and process the chunks in parallel. Then after it, we aggregate the results, either assemble the pre-processed processed chunks, or we just merge the results from each of the data sequence. Concerning the video, in the scenario of video, we will divide the video into the parts, and we will we will process each of the part in parallel on the different core, and after that we will assemble the video. We will concatenate the video and obtain the sequence. Okay, so first up is the first step, divide. Concerning divide, first we need to check. So first we need to check if I have FFmpeg available. So as you can see it, I don't have it. Therefore, I need to load the module FFmpeg. Module, sorry, load. Okay, clear. Okay, let me check FFmpeg version. Yeah, here it is. Okay. Let me. Okay, we don't. Okay, yeah, Edmond, we don't need to create three directories, so this is only for my purposes. You can do it in everyone in the same directory. Okay, so let's go on. First step is to divide. To divide, we will use following command. So here, let me paste it. Let me copy it and paste it. Concerning the okay. I already done it. So concerning the example here, first thing that I will do is I will run this on the compute nodes using sround, and I will have one task to do this. And this is the part of the FFmpeg that actually this splits the video. So these are the old switches. So basically, so I'm copying both the video and audio, and I'm using segment filter, which chops the video, and the segment time is 20, so 20 seconds. And the segment list is parts.txt, and the output parts are in the form from part 0 to part 4. I think because we have like we have this is the number of them. So let me check how many. So I already run the command. Who executed the command? Raise your hands. Okay, great. Okay, regarding this, let's just check the output. Okay, let's check the results. So concerning the results, we can see that we have the original video, then we have 5 parts, part 0 to part 4. So these are these parts, and we have this parts.txt. Let me see what the part.txt means. Okay, it just contains the list of the output parts that we did. So the first, we can check the first step. So the second step is the step that we will focus more on. Okay, so as a first step, we will follow the same. We will use the same command that Dower did in the last 5 minutes in the previous part. However, we will process this on the different segments. So in order to do this, we prepared this FFM, this is this SBatch script. Concerning the SBatch script, you can download it or you can use nano command. So ffmpeg.1 sh. Okay, nano, and I will just copy. Okay, just copy. Okay, first, just let me tell you in short concerning. So the job name will be ffmpeg. The output log will be in the ffmpeg.txt, and we'll have 10 minutes allocated. The, let's say, time limit would be. Although we will finish this under 10 seconds, and we will use reservation furry. So you can use now, with this account, you can use now reservation furry, but with your own accounts, you cannot use this reservation. The Slurm will give you an error if you call reservation that you're not part of. Okay. Okay, concerning this, the commands are the same. However, instead of 1, we have 5 commands. So for each part. Okay, I'm pressing Control X to save and click and saving this. And I'm exiting FFmpeg. Okay. Now how do I run it? How do I run this SBatch script? Yeah, just using SBatch. Okay, great. Okay. SBatch ffmpeg1. Okay, I already submitted, but I will use this watch sq minus me to see interactively how much do I need time. So here the script is taking, let's say it's 16, 17. We have how many seconds? So we have around 20 seconds. We need 20 seconds to execute this script. However, this is not good. This script is pretty naive because if you see the script here, the biggest disadvantage of this script that is executing one srun at the time. So first it will send this srun to the Slurm. Then it needs to wait before the second command needs to wait before the first one is being executed. So we are not yet here. We are not executing this in a parallel fashion. Therefore, this is not a good approach. So although we automated this, let's say we are not typing 5s runs, the execution is the same as Dower did before. Therefore, we need to we will use next script which does this a little bit different and allows us to get parallel execution. Okay, first off, the script is here. This kind of script is processing is starting similarly as previous one. However, here in the 5th line, we are using, let me copy this and create new script. So ffmpeg.sh. So as I said it, we have the first attributes. The first attributes are the same. However, the number of tasks is not equal to 1, but is equal to 5. Okay, and this 5, so basically we are telling the Slurm to run 5 jobs and hoping that it will or that every job will get its own. In order to get non-blocking effect, we need to put this and ampersand symbol at the end, which sends this sround request into the background, therefore letting the next sround command to continue executing, to continue submitting the job. And the final element is this end task is equal to 1 overlap. How this overlap, this without this, if we don't put this, the SRAM will repeat each of this line for 5 times. And now with these end task is equal 1 and overlap, we are saying that each line represents one task in the job. Okay. Okay. Great. I cannot exit. Let's try the. You need to. Let me. Okay, I will save this file. Okay, as watch. SQ means me. Okay, you just put Ctrl+C. Yeah. I need also to. I'm doing this automatically, so I forgot. I forget. Okay, so let's go back to the task. Let's go back to the task, and let's try to execute this FFmpeg2 using sbatch. So I will only use this. Okay, now let's see how much time does it take to execute this job. So as you can see this is around, I don't know, 6 seconds. It was really, really fast. Let me okay, 1, 2, 3. It's like around 5 seconds. This is roughly 20 divided by 4. We need to also count some other times. So we have a speed up of 4 times. 4 times we are processing faster, and we only what we did is split. What they did is split the data, and now we process each of the data chunk in parallel. There are a lot of things. This can abstract to a lot of problems, which we call embarrassingly parallel problems, where there is no where you process each chunk of data with the same program, with the same instructions. And at the same time, there is no some kind of dependencies between each chunks. So this can be one of the role models of how can you speed up your applications and utilize more these computing resources on the HPC. Okay. Okay, so this is good approach, and basically this batch script actually does the job in the way that we want. However, if we, let's say, we have 2 hours with 2 hours video, and we process each chunk in each chunk has 20 seconds. This can be really cumbersome to write. I don't know how many lines. How many lines do we have? It's like around 1,000 lines. So this can be really cumbersome, and it's not the way. Therefore, we have a so-called array of jobs. So instead of manually listing the jobs, we can run all the jobs as an array. So concerning the array of jobs, we have the example here. So this is the third approach. How can we parallelize the processing of video using FFmpeg? Now in this approach, we here here the script starts really similar as previous one. However, we have the the third line which defines the output, is written like this: ffmpeg3%a. This %a represents a job label or job index, how you say. Okay, concerning the job index, how many jobs we will run in the array of job, we will define it like this. So we put it with this switch array 0 from 4, and here we will run 5 jobs from 0 to 4. It can start also, let's say, from 5 to 10 and so on and so on. However, be careful how do you index, what are the how do you use this index here, because we are all our parts, let's say ls. Okay, this our input parts here, part 0 to 4 have indexes from 0 to 4. We will use this index to select each of the part. So how do we continue? So here we are calling the srun ffmpeg like usual. However, we are not giving it a number of tasks. Here to address certain parts, we are using this slarm array task ID. This slarm array task ID means that we this is basically environmental variable, and it's equal to index of job inside of the array. So we will not run only one job, but we will run 5 jobs. First job will have 0. The second job will have 1. The third job will have 2, and so on and so on. So let's try to let's copy this thing. Let's put none on ffmpeg3.sh, and let's copy this thing. Okay, the older parts are the same. We can also add here the reservation. Try to use reservation as much as possible, of course, if you have the reservation for it. If you're part maybe of some kind of project, or in your case, several of you are part of the summer school and so on and so on, maybe they will provide some kind of reservation. Try to ask. Okay, now I need to call sbatch ffmpeg3sh and watch. Okay, and it's running. Okay, as you can see, it already did the job. So here it is faster than the. Did you module load? You need to do it's FF 2F capital F in the module load. Okay. No, it took me a while to get adjusted also for myself, so don't worry, you will get proficient when you start to work with in the HPC environment. Which is not that friendly as our personal computers are. Okay, now this is it. Okay, so we finished this step. So if I do the ls, we have our results, resulting videos. These videos are out part 0 to out part 4. So we have these things. Therefore, we need to assemble this with these chunks into video. Therefore, what we will do here, we will also use, now this is not, we will also use the FFmpeg, and to do this, we need to have a file that has the name of the videos that will be concatenated, that will be merged. Therefore, you can download this video, download this file, or create outparts.txt and copy with nano and copy these lines into the file. However, you can also use this command, and which does it automatically. This is part of the, let's say, this is a little bit advanced bash, but let's so we will not go into details. So I created this. Let's show the content of the outparts.txt. Okay, this is what I want, and this is what I got. So we are good. Okay, now regarding this, when we have this outparts.txt file, we can run the command for assembling. So we are also using FFmpeg. However, we are using concat filter for concatenating these chunks, and the name of parts are listed in the outparts.txt file, and the output file will be outlama.mp4. Okay, let's copy this thing and let's paste it here. Okay, so regarding this, we finished, and let's see if we have the output. Here it is. So the output is outlama.mp4. So let's check the resolution. ffprop out. Okay, if we check the resolution, here, we will see. Okay, Major Brown, the HV2 resolution is 640 times 360, which is desired resolution that we wanted to do. Now you can download the video and see for yourself that the video is the same as the one that Davor did. However, in this case, we harnessed multiple processor in order to parallelize the processing. Okay, Do you have any more questions about this part? Okay. Okay, as we are nearing the end of the workshop, we can we will we are nearing the end of the workshop. We'll continue. Therefore, we will try to perform all of these steps at once. So concerning the previous cases, so we needed to manually to divide the chunks into the video into the smaller chunks and to process it. However, some applications support so-called multi-threaded processing, where the program itself can use multiple cores or multiple CPUs. So there are a lot of algorithms that can be parallelized in this kind of way. And luckily, FFmpeg does this, also supports this. However, let's just imagine for a moment that we don't have the access for the FFmpeg. Let's say in this moment someone has removed FFmpeg from the cluster. How do we continue on this workshop in this hypothetical situation? We can install the FFmpeg, but we encounter the difficulty as we don't have any rights to add new programs. Therefore, we need to come up to a different strategy, and this strategy relies on using the so-called containers. The containers are, let's say, closed environments that resemble virtual machines. How many of you did use virtual machines? Let's say using Linux inside Windows or other way around. Raise your hands. Okay. So the concept is really simple. You are independent with this kind of software. You are independent. You can run Linux application inside a virtual machine. You can play with the virtual machine, add something, and you will not influence the host. You will not influence the computer that you are running on. The similar thing goes for the container, but they are much more lighter version of the virtual machines. However, we don't have although the containers are really other containers are a really interesting topic. We don't have time to discuss more detailed. In order to, let's say, if you want to get if you want to know more about containers, please visit our next workshop that will be held on 23rd of June, and we will talk only about the containers. But so from now on, we will use the container. We will use container that is provided on this link. So here you just copy the link, and as previously, use wget, and you will download the container in which we installed FFmpeg. Okay. Did you try? Did you download it? Raise your hand when finish. Okay. Maybe there is some kind of if you encounter that the downloading is slow, this is the fact that multiple of you are downloading at the same time. But after you download the container, the only thing that you need to do is to copy this command. Concerning this command, let me explain to you. So here, unlike in the previous cases where we run our FFmpeg under the cover of the, how's it called, the environmental module, here we need to run the FFmpeg under the container. So, and how do we do this? So the first we call srun and task. Now, because we can harness more processor, we specify that we will use 5 processor per task. Okay, and then we need to write magic word, and magic words are obtainer exits, which means that sorry. Okay. Which means that we are running the application, inside the container. So inside the container ffmpapply.safe, this is the name of the container that you downloaded. Okay, this is, I will just change directory to another folder. Okay, there is this container. Under this container, run ffmpeg command. Okay, and this is what I will do. Okay. Okay, and here I am working. Here I already processed the video. So by using five CPUs. Okay. Concerning this, we can continue. Regarding this, you can see that here an interesting data is this speed, which means not the speed of processing. So it was the video is processing 16 times faster than it's being played. Okay, so you just divide the number of seconds divided by 16, and this is how much seconds did we need to process this video using 5 processors inside of container. Okay. Great. We have questions. Okay, you cannot run Docker containers because the HPC cluster only supports Optainer. However, you can there is a way to transform Docker containers into Optainer ones by using Optainer pull command. Okay, so it's really the technologies between Optainer and Docker is similar, but the Docker is not compatible with the HPC cluster. We will discuss this on the next workshop that we are preparing at the end of the June. Okay, great. Do we have any more questions here? Hello? Okay. If not, let's go to the next. Okay, okay, by default is in Slovene, but if there is a need for presenting in English, we can always do this. Sorry. Someone has left the mic on. Okay. Okay, let's go on. Let's continue. So this is, and till now in the workshop we used only processing unit, central processing unit as the workforce as the compute units to process our video. However, we can also use GP. We can also use GPUs to process the video. Okay, concerning this, we will switch to next chapter of this unit. Okay, I'm posting the link on here. Okay, in the last chapter of this unit, we will use graphic processing unit, or GPU in short. Let's say a little bit of background on the GPUs. In the beginning, the GPUs were used for representing they're using for quickly rendering images on screen, and due to this they evolved into really specialized architectures which favor parallel processing. Current GPUs are more than the means for rendering images on the screen. We can use them also to optimize. We can use it to optimize, to parallelize, to accelerate numerous applications, including some scientific simulations to neural networks. And GPUs can be used also to process video, and there is a FFmpeg that there are versions of FFmpeg that supports processing on video. However, this version that we have in the environmental module doesn't have the support for processing on how's it called, on the GPUs. Therefore, we will use once again containers. Now we will use, to build a container, we will use this command, obtainer pool docker, obtainer pool. This command will pull the container, which is originally intended for Docker, but it will, when pulling it, it will transform it into obtainer compatible.
So yeah, probably another internet connection crash from Ratko. Let's wait a bit till he comes back. Yeah, in the meantime, for those interested in a container shop, there will be one in June. I already pasted the registration form into the chat if you are interested, but it will be in Slovenian, as we don't have the materials in English prepared yet. So that is for the autumn. We will translate and prepare all the materials in English, and we can have one later in autumn, sometime in September or October, for those interested. Otherwise, if you are from Slovenia and you know Slovenian, you can join already on the first one. It will be on the 24th of June. And you will be able to learn how to prepare your own containers and execute them on the cluster, on multiple nodes, on multiple CPUs, and so on. So we wait a minute or two till Radko comes back online.
Greetings after the second crash of my internet. Not I'm hoping that this will be my last. Okay, great. I think you can hear me. So let's continue. Let's continue to. Okay. So here I am. So here we are. What's the last thing that you heard? Did you try to build this container? Okay. Okay, great. So let me reconnect the cluster, and let's try to. We are nearing the end. The end is near. Okay. Okay, so here I will, as I said it, I already have the container built inside and built-in container with the FFmpeg that supports NVIDIA. Why that supports executing on NVIDIA GPUs? Why is this needed? However, the GPUs are programmed with a different language and have different architecture than the CPUs. So a lot of software that runs on CPU doesn't run on GPUs. We need to rewrite these programs in order to be compatible with the execution on the GPUs, and somebody adopted this FFmpeg, and we will use this. Similar for you, if you have some software if you want some software to be run on the GPUs, you need either to find the software or to adopt it to run on the GPUs. In other case, at least try to see if your software supports execution with multi-core processors, with multiple processors. Okay. Regarding this, let's first execute this line, and in this line we will inside of the container FFmpeg NVIDIA CIF execute check the FFmpeg version of the version of the FFmpeg. Okay, let's copy this. Okay, if I'm copying here, so I'm executing this where? On login node or on compute node? Where did I execute this thing? This line, where did I execute? I execute this on the login node because I didn't use srun. Okay, but this is really lightweight command because it only just prints the text, gets the output text. Okay, so I'm not processing it. Okay, let's go on. So we will try to process this video on GPU. First, we need to export these environmental variables which are needed for FFmpeg to run correctly. Okay, so we export this environmental variable NVIDIA driver capabilities. Now, this is FFmpeg specific. Maybe sometimes you will need to do, for your problems, you will need to export some variables, maybe you will not. Okay, the thing that we need to need to be focused is this thing, is this command. So what we need to do here is this thing. Okay, first srun. Now the partition GPU. So when we are running our, so far we run on the partition all, which is default partition on the HPC cluster. However, this partition doesn't have any GPUs. So we need to address GPU partition of the cluster. Now, the other cluster has different partitions, so you need first to be acquainted with the partitions. However, on the harness cluster, the partition has name GPU. Okay. Now, the other switch is how many GPUs do I want? And this is srun thing. Now we are going to run inside the container. When running inside the container on the GPU, we need to use this NVIDIA switch, which allows to connect the host libraries, NVIDIA libraries, with the container ones. In the other words, the container with this switch sees the GPUs, and it needs to be specified. Otherwise, the obtainer will not see, the container will not see the GPUs. Then we list the FFmpeg, and now then we list the specify the container, then we specify the command that we will be executed, and so on. So here the novelties that we will use CUDA hardware accelerator, and the rest of the output format will also be in CUDA. So basically, the CUDA is the language for programming NVIDIA's GPUs, and basically they will use CUDA compatible binaries to run this thing. Okay, let's run this. Let's run this thing. Okay. Regarding this, now the speed is 20.1. 20.1, even 50.2. So basically we have now, if you remember correctly, the previous speed was around, I don't know, was around how many? 12, 11, 16. Now 16. Now the speed is around 21, even goes to 52. So the GPU processing, really using GPUs really does pay off. However, to execute something on GPUs, you need to have your software needs to be specialized, adopted, or failed, permission denied, container creation failed, NVIDIA. Okay, yeah, it needs to be adopted. Okay. NVIDIA contains CLI file with exit, container file, permission denied. Maybe to do this obtainer. So this is obtainer pool, Edmund. Exited with the code. Okay, Edward, you will discuss this with the Dower. However, we need to we are a little bit running out of time. Although we finished this chapter, we are not finished with the workshop. In the last part, I will try to explain you how to connect to the cluster with private public key. Okay, so let me stop share the video, my screen, and just
Okay, we had another network crash. The interesting thing is that he is located at the Faculty of Computer and Information Science, and this is the internet he's got. So what can we do? We'll just wait a little bit till he returns. Any questions in the meantime? Repositories for this workshop. I mean, for this one, not really. You have all the code and examples on the web page, which we pasted multiple times. So you have all the code there. We don't have a dedicated GitHub for the code from the workshop. So everything is here. What do I personally use the HPC for? Well, firstly, for harassing students. So they have to do their assignments on the HPC. And otherwise, usually training neural networks, mainly, at least recently.
Okay, so I was so the third time is a charm. So I was too much eager to. I was challenging my fate, and this is what happened. So I will be humble now. I will not say that this was the last time that my internet will break on this workshop. However, let's continue. This is not the reason not to talk about public-private key. Concerning this, we will just give just let's say quick explanation between public and private key. Let me just give me minutes to just set things up. Okay. Now, the public-private key is a mechanism to allow passwordless logging on the server. This is more secure way, as someone can steal your password and gain unauthorized access to the FPGA cluster, to the HPC cluster in our case. To illustrate this, let's imagine that we have two persons, Alice and Bob. So Alice and Bob's are, let's say, lovebirds in love, and they are keeping their relationship secret. And how do they communicate? How to communicate between each other? Basically, they adopt the concept of the key and the padlock. A key and the padlock. Regarding this, this will allow them to have a secure way to communicate. So during one coffee, the Bob shares the padlock with Alice. And when Alice tries to send letters to Bob, it places letter in the box and locks with his padlock. Now, when he sends the padlock through mail, no one can tamper with the letter, as the only one that has the key is the Bob. The box can disappear, however, it cannot be broken into. Therefore, when the Bob accepts the box, he can unlock with its key, and this is called the ciphering process. The ciphering process. However, however, we can reverse the roles. So let's see that. Alice receives a lot of love letters every day, but only is interested with Bob's letter. How can Bob does this? Basically, Bob, when sending its letter, he also sends his private key. So when the Alice receives the letter, she will know that it was sent by Bob if the sent key opens the padlock that was given by her. This is what we call a signature. And basically this is how we log in using private public key. So in the sense we share our public key with the server, and this is something that is the public key can be shared. If someone knows your public key, doesn't matter. Okay, but the private key needs to be private and needs to be confidential. However, so how the server does this, it encrypts the messages with your private key. Then this messages is sent to the server, and the server takes from this encrypted messages the private key, and if it's matched with the public key, then you gain the access to the server. Okay, this is called logging with public private key. However, there is one more danger. So let's say that we have in this scenario a person called Tom, which is close friend with Bob. However, Bob doesn't know that Tom is secretly in love with Alice, but he plays dirty. He wants to he steals the Bob's private key without its knowing, and now he can communicate with Alice as Bob, and that's not. And basically, this is happening a lot. Someone can hack into your computer and steal your private keys, and gain the access to the servers. Therefore, Alice uses instead of two padlocks, she uses, instead of one padlock, she uses two padlocks. So when we are connecting with this on the server, besides using public-private key, we are also using so-called OTP or one-time password, which can be sent through SMS or applications or so on. Therefore minimizing the unauthorized access. It will be really rare for user to have both the private key from non-authorized user to have private key and the one-time password. And this is how we minimize. This is the approach from two-factor authentication, which we can lower the risk of unauthorized access. Okay, although this is in Slovene, in the latest, let's say, 1 year ago, harness has the harness requires two-factor authentication to connect to its server. As you noticed, we didn't use two-factor authentication as the training, as the users that are part of the training group do not require this two-step authentication. However, if you if you become regular user, then you will need to set up two-factor authentication. Okay, now this is it. This is my last slide. Before we conclude the presentation, we will also try to set up public-private key on our laptops. Okay, so here, what will I do first is that I will log out from the HPC cluster, and I will be present on my machine, on my laptop. Okay, so log out from the cluster. Okay, we have a question. Okay, this is now what kind of tags are you trying to mitigate? This is out of my reach. Concerning this is out of my reach, but this is, I don't know, I'm not a cybersecurity expert. But a lot of data can be stolen. A lot of data can be stolen, including the private public keys. Now, something like that. So this kind of attacks now. Okay. Okay. So regarding this, we will need to visit the instruction for setting up public and private keys are in the workshop. Concerning this, you go to the using computer cluster and connecting with the SSH key. Okay, I will post it here. Okay. So concerning the so you can follow this or not. Now in order to generate SSH key, we will use this command SSH, let's say SSH -t. And we will use, so this is command for generating a private public key, and the type of the encryption is this adds a signature scheme. And we can optionally add the label. I will not add the label. Okay, now I will do enter, and it will ask me where to save the key. And I will save it here. So please remember this file, where it is. Please remember it. Okay, I will put it, if I leave it empty, it will be here. Here stored now, I already created it, so I will overwrite it. Yes. Now it asked me for the passphrase. I will not use the passphrase. This is optional. Maybe it's better, it's more secure if you have passphrase. But I will not do this because we are running out of time. And here we get this kind of art, and we now know that the key random art. We now know that the key was generated. Okay. Now what I need to do is I need to find where my public key is. So where my public key is, so here I will do, so this is my folder. Okay, so I will go this. Okay, who generated the key first? Raise hands. Oh, okay. Now remember this directory where it is. So I will cd into this directory. So I'm running this on my laptop, not on the cluster. Okay, ls. Now I'm going. This is the key that I want. So we have two. This ID without pub and with pub. With pub means that this is the public key. And this is the part of the key that we need to share with the HPC cluster. So I will do cat. Okay. And this is the key that I will need to that I need to copy. Okay. Copy it. Who has copied it? Who has found it and copied it? It would be different than mine. Okay. Regarding this, so this we generated key, but we need to register it with the server. And how do we register it? We return to the fido.sling.c to this page. Okay, I will log out. So once again, you need to what I was 43. You need to log in. Okay. Now when you log in, okay, did you log into the FIDO? Raise your hands. Okay. And in this section, in the right part of the screen, you will see SSH public key. You go to the add, and you just copy the key you just paste the key that you previously copied, and click set. Okay. And after this, we are not finished yet. We need to save it. And if you can see the key here, then you finished the registration procedure. Okay? Who did this? Raise hands. Okay. If I was too fast, the detailed instructions are here. Okay, just go through it. Okay, and if I'm lucky, because I have 300 public keys generated so far, I will log in without the password. Yes, and I logged it without password. Okay, who succeeded in that? Great. Great, couple of you already did this. And this is where where my part finishes, and this is, let's say, the end of this workshop. I will return the bat to Davor in order to conclude this workshop.
Okay. So with this, we almost conclude today's. Just a moment. Can you hear me? Yes, you can hear me. Today's workshop. I would like to ask you one more thing, and that is if you would be kind enough to fill out this survey, which I pasted link into the chat. I just short few questions so that we get some feedback
how were you satisfied, and if you have some with the how are you satisfied with the workshop, and if you have some additional comments maybe. I all invite you to join us in the future on the future workshops. You can find all the workshops on indico.es.se. That's the page where you also registered for this workshop. There are some in English for you who are not Slovenians, so there is a little bit for everyone and different topics, of course. As I mentioned, on the 24th of June, we will have workshop on working with containers, although that will be in Slovenian, but of course we will organize one in English also in the future. I expect it to do one in autumn in English. Thank you for joining, and see you next time. Bye.
Bye.